Lorena to start with the webinar. Please.
Thank you, Simon. Let me know if you can hear me properly.
Yes.
Simon? Yeah,
yes.
Okay. So good afternoon and welcome to all of you. I am very pleased to have you attending our 9th ELISE Action webinar. My name is Lorena Hernandez. I work as a project officer at the Joint Research Center of the European Commission. And in particular, I work for the European Location Interoperability Solutions for E-Government Action, better known for its acronym ELISE. I will be the host of this event together with Simon Brecha, who will be helping me, as you've just seen, with the logistics and the moderation of the question and answer session that will come afterwards. Next slide, please. Okay. So very shortly, for the benefit of those who are new to the ELISE Action, it is worth saying that the ELISE Action is one of the 54 actions funded by the ISA2 Programme. ISA2 is the European Interoperability Programme aiming at providing cross-border and cross-sector interoperability solutions for all public administrations, businesses, and citizens. The ELISE Action is unique in the sense that it is the only action that actually focuses on location dimension as a driver for enabling the digital transformation. Next slide, please. Yes, so within the context of one of the ELISE Action activities, which is the knowledge transfer activity, we are organizing periodically these events, these webinar series. The purpose of this event is actually to engage in an agile way with topics of relevance to the digital transformation by harnessing the use of spatial data and technology. You will be able to find all the webinars that have been organized so far, together with the respective presentations of recording in the ELISE journal page, which is put in the slide. Yes. So today we have. Okay. Yes, this is the slide. Thank you. So the topic that brings us here today are the digital twins. We cannot deny that digital twin is one of the trendiest and most exciting topics in these days. And who has not heard of them yet? They have come to us as a kind of game changers in the digital transformation process, promising great benefits in terms of efficiency, automation, and decision making, also even for the public sector. But how much of hype and reality is actually there? In spite of not being a new thing, at least in the manufacturing domain, as we will see later, it is an idea that is being uptaken very quickly in any domain you could think of, as basically any physical asset can have its digital version. From a turbine to a building, a forest, a city, even a person can have its virtual double. These virtual doubles would allow to apply if scenario simulations to understand how they would behave in a given condition. And therefore, they help us uncovering insights and potential problems before even experiencing them. And as you can imagine, the location dimension in digital twins is of fundamental importance as it provides context information. This location awareness allows us to have the complete picture, let's say, of the relationships and the interactions between places, people, and devices, be it relative or absolute, or be it geodesic based or not. So to answer to the main question that we were proposing right from the title, that is, are digital twins ready to embrace location information? We have today with us Glenn Wackenberge and Daniel van der Broeken from Q11, who together with us from the JRC ELISE Action team have carried out the research for this webinar. So the colleagues from Q11 will give the presentation, which is divided in 4 sections. Next, they will start by setting the scene, explaining amongst other what a digital twin is, how they were originated, and what elements make a digital twin. Next, we will see how some digital twins look like by showcasing a gallery of digital twins, initiatives, and applications that are making use of geospatial information. We will see digital twins at different stages of deployment from different scales and domains. In the third section, will be highlighted specifically the role of interoperability, including the recent work from the standardization bodies. And we will finalize by underlining some challenges ahead. Okay, so before starting the actual presentation, I would like to give you some instructions. The presentation will be of around 40 to 45 minutes, and afterwards we will have the question and answer session. Please use the chat box if you have any question or comment on this. And I remind for those who have maybe just arrived that there will be some pollings during the presentation. And actually, now it's time to start with the first set of pollens. And for this, I hand over to Simon. Thank you.
Thank you, Lorena. So before we start, let's say with the webinars by our colleagues from KU Leuven, we would like to ask you a bit questions about yourself. So you are kindly asked if you may answer to following questions. So what is your affiliation? So where are you coming from? Have you attended any of our webinars before? And what is your current level of knowledge on digital twins? So is it very low, medium, high, or very high? So let's have, let's say, another 10, 15 seconds to answer. And I think with that, yes, another 5 seconds, please. Okay, thank you very much for your answer. We'll end the polling and share the results. So it looks like that most of you are coming from the Academia and Research Center. Most of you haven't attended our webinars, and most of you has the medium level of knowledge on digital twins. So I think it's a very interesting inputs for Glenn and Danny, and I will give now the floor to Glenn to continue with the presentation. Please, Glenn.
Thank you very much, Simon, also Lorena, for this nice introduction. I hope you can all understand me well. Like you said, indeed, Sim, it was very interesting to see these results, to better know our audience and what they expect from this presentation today. To be honest about the final question you asked to the audience, I don't or didn't consider myself as a digital twin expert. We rather looked at this development from our expertise, from our knowledge from the geospatial domain, and see to what extent everything related to digital twin could also be relevant to the things we are more familiar with in the geospatial domain. Because we believe, and we are still convinced about it, that geospatial intelligence and interoperability, they both are key enablers of the creation and management of digital twins. So we believe the geospatial community can contribute to a strong extent to development, use, management of digital twins. Why do we believe that? Because we see that many of the applications that already are in place, but also applications that are planned to further be developed in the future, they are influenced to a certain extent by location on one hand, and also the aspect of data. Data are often considered or often named as the fuel for running, operating these digital twins. So we believe that spatial location data are very important to them, should be considered as a key building blocks, but not only the data itself, but also the technologies and the geospatial standards should or will probably contribute a lot to the creation, management, and use of digital twins. And therefore, we believe that the existing geospatial data infrastructures, the data ecosystems already in place, should be considered as a starting point. They should be further developed, further upgraded or developed, so new development should be taking place. But I think we believe that it's important to already look at what is already in place in our domain, and to what extent can we build further on it to further develop and to contribute to the creation and use of digital twins. So the first part of my presentation will deal with the context, definitions, and the frameworks. And I would like to start with this quote. It's a quote from the European Strategy for Data that has been released earlier this year. And I believe it's valuable for many reasons. To begin, it's one of the very first EC policy initiative policy documents in which the concept, the notion of digital twins is mentioned and recognized. On the other hand, in addition to that, it also strongly highlights the importance of data. So again, like I mentioned before, data will be the fuel for the implementation of transformative practices, of which digital twins are considered as one. And then thirdly, it also includes a first definition of what a digital twin can be seen of. It's a virtual replica of a physical product, process, or system. I think this basic definition already, to a certain extent, explains what additional digital twin is about. I think it's important, especially if we see the level of participants, quite a lot of participants from the academic domain. Now, if we have a look at to what extent the concept, the notion of digital twin is already present in current scientific literature, it's very interesting to see there's a huge increase on the attention, the extent to which there have been publications, scientific publications on the topic. It's really very recent. So I think until 2015, you had less than 10 publications worldwide on the topic. And then afterwards, it started to increase. So in 2016, it was, I think, around 20, and then you had 100. And there really was a peak. So almost half of all the around 2,000 academic publications on the topic of digital twins, almost half of them have been published last year. I think it's really a striking observation if you look at to what extent did the scientific community already look at this notion of digital twins. And so far, the key domains that were looking at this concept were mainly, on one hand, computer science. On the other hand, it was also engineering was a quite important domain looking at digital twins. While you see in geomatics, earth science, etc., there was so far very few attention on digital twins. So left side, I showed the scientific attention. Right side, I use the hype cycle of Gartner, the 2018 one, where digital twin was really at the peak of the hype cycle. So they expected quite a lot of it on a very short notice. I think definitely something to further discuss afterwards in this webinar, to what extent digital twins have been able to fulfill the high expectations of it. Etc. So that's something to be further discussed afterwards. So we are definitely looking further to your opinion on these numbers and your experience in to what extent digital twins still are popular and relevant. Now, if you look at our domain and at the same time at the global level, we see it also in the recent UN GGIM vision document on the future trends in our domain. Digital twins is recognized as one of the technologies that will play a primary role in transforming our domain. I think that's also a very interesting observation. This document mainly looks at digital twins from the idea or the concept of smart cities. So they see as the future of smart cities will only be significant, will only be effective if they take into account digital twins. I think that's very important. And it was also only in this version of the document that digital twins concept have been introduced. If you would like to provide your feedback on it and how the geospatial domain should look at or should take into account, take into consideration everything with regard to digital twins, there's still an ongoing global consultation on the document, which, to be clear, is not only about digital twins, but just to show you, highlight again that also our domain is looking at it. And in this document, it especially explores, or it especially sees an impact of digital twins in terms of the data in our domain, the standards we are developing and using, but also the innovation of our domain. So just a few examples illustrating the increased attention at this stage. Now, if we go back to the real origins of the digital twin concept, a concept that is now being increasingly used, but it's not a fully new concept, because it already dates back from the beginning of this century, where often other terms were used, but the idea, the underlying main idea behind the digital twin was already in place, mainly on one hand in the Greaves mirrored space model, where the elements of the digital twin, in the sense of you had a real space, then you had a virtual space, and then you had a link or a flow of data from the real space to the virtual space. But also oppositely, there was a link, a flow of data or information. That idea was already recognized in Greaves' mirrored space model, who rather, on the other hand, looked at the product life cycle. I think there the idea was that this connection between the real space or the physical twin and the virtual space or the virtual twin, so that connection should be recognized and is relevant throughout the entire life cycle. So when you start creating a car, producing it and using it afterwards, you should always take into account, or you can always rely on that notion of a digital twin. So the connection between those two systems is relevant throughout the entire life cycle. So that's one line of work in which the digital twin concept was very relevant. On the other hand, it was also in the space sector. NASA, they have been for a long time very interesting and working on developments very similar to digital twins, but then mainly for the production and then especially afterwards the operation, maintenance and repairing of their systems in space. So they always had a virtual or some originally more physical twin of their aircraft, their vehicles in space. They already had it here on the ground. Which allows them to simulate, to assess the conditions on board. And I think the Apollo 13 rescue mission is often cited as a really well example where the NASA already relied on a mirror system to allow engineers and astronauts to determine how they could rescue the mission. So these are two examples. I think these are often cited key sources of information with regard to or where the digital twin concept has been introduced. Here, quite many examples nowadays showing that the concept, there's a growing number of applications, many different sectors, really a variety of domains in which the concept and technology is applied for many different purposes. You see also more and more, maybe a little bit more recently, while originally mainly it was in the manufacturing domain, but more and more you also see that governments are recognizing the importance or the relevance of the digital twin concept and related technologies for their work in many different domains. What we already see here, what we can highlight here is that even each of them or in each of these domain sectors, already location is relevant, very relevant in some cases in a certain way, which already shows the potential for further location enablement of digital twins. Now, if we look further at the definitions and what are now the key elements that constitute digital twins, we should first tell or be aware that there are there's really a variety of many definitions of what a digital twin is, what are now the key elements, often highlighting very particular elements or often focusing on the application of digital twins in a particular domain. Now the key elements, or at least two important elements as we identify them here. So on one hand, you have a physical model and then a corresponding virtual model that are connected. So that connected is a very important element, but also the fact that that connection is established through the generation of real-time data, probably through sensors, Internet of Things technology, etc. But at a real-time connection, you can see that as an important element of what constitutes digital twins. Now you also have a set of definitions that rather highlight the main purpose of why we should develop, why we should create, why we should use digital twins. Also the definition we use or the definition we propose here mentions about the key purpose. It's about mirroring, but afterwards also predicting and controlling the activities and the performance of the physical twin. So if you see these two things together, I think you really see that the time aspect is quite crucial. Time aspect in the sense of real-time data, but also time aspect that we don't look at the present, but it also allows us to look at the past and especially at the future. So the what-if simulation, what-if scenarios, they're also recognized as a key element of digital twins. This slide's about what's now precisely so new about it, or what is now are the reasons why these digital twins are becoming so hot or so relevant in these days. And here we rely on the work done by Deloitte on this domain as part of their work on technology trends and assessing the relevance of different technologies. But they were able to identify a set of factors that explains why the capabilities of digital twins recently has significantly accelerated. They identified 6 factors: simulation, new sources of data, also interoperability. For them, that's a key reasons why digital twins are becoming more and more prominent. The visualization aspect, also a very relevant part of digital twins. Instrumentation refers to the fact that you can collect that information, the data that you need for operating these digital twins. You can use it with even more and more smaller sensors, etc. So also from the instrumentation side, there are some important developments, but you also need the platforms to be able to operating these digital twins. Now summarizing, you see especially huge developments, very recent with regard to the availability, accessibility of data, the sensors, that's also very recent, those developments, very important. Computing ability, also a crucial factor, and then the visualization. I think those four, they also show why digital twins nowadays becoming more and more relevant, but also more and more possible to put into place. Now, if we rather look at it from the perspective of concepts, we from the geospatial domain are more familiar with. You can see it from these two figures. The left side is a scientific publication that shows the difference between what is now a digital model, what do we consider as digital shadow, and what do we consider as a real digital twin. And there, the key element is really the focus on the connection and the integration between both, but also the extent to which the data exchange between the physical model and the virtual model can happen in an automatic way. That's also an important aspect. So it's about data being transferred from the physical twin to the digital twin, but also data information being transferred in the opposite twin, and then the extent to which this can happen without, or can or could happen in the future, without any human intervention. And the right side of the slide rather shows how Bentley looks at it currently, and they place digital twin in the development from 2D over 3D towards 4D, where they really put a lot of emphasis on the change synchronization, so the continuous updating of the virtual twin based on the data received from the physical twin. That's really very important. Then afterwards, the flow again towards the physical twin. But also the visualization aspect, also key. So new ways to visualize information, new ways to visualize your virtual twin, and then the entire analytics part, also a key aspect of it. And then the final slide of the first part of this presentation looks at the issue of maturity of digital twins, or rather look at some ideas on how should I say it, frameworks and models that allow us to assess the level of development of different twins. I think these kind of frameworks are interesting for many different purposes. So they allow on one hand to better explain the current status of development of a particular digital twin, but in the future or the now, they could help us to compare different digital twins or different similar digital twin. For instance, the digital twin of city A, compare it to the digital twin of city B, or what is now the level of development of each of them, what are its key characteristics. I think the level of assessment comparison is an interesting element of these maturity frameworks, but also they tell us a little bit more about what now really constitute the key elements of a digital twin. So on the right side, and I use the model from Arup, which identify 4 dimensions as part of their digital twin evaluation framework. So it's about autonomy, the ability of the system or the twin to act without human input. It's about intelligence, also an important element. Learning, and even the aspect of machine learning that more and more becomes important or could become important. And then the notion of fidelity refers rather to the level of detail of the virtual twin. So how many parameters are copied in the virtual twin, how accurate is the information, how detailed is the information. That's a crucial aspect when you look at the key elements of a digital twin. And then the figure on the left side, it's quite similar. It also shows the evolution from a simple data model to a real digital twin, where you can identify many different steps and also many different elements that constitute what a real digital twin is about. So the model here is the one from IET and Atkins that's linked to the developments in the UK, but they see a different, so they really show the different step from a simple model, travels linking your 3D, 2D model with data, the continuous or the element of the real-time data is also identified as them as an additional step. Then you have the aspect of the two-way data integration and interaction. And then finally, for them, the final step is about the autonomy. And they see each of these levels, they have their own level of complexity or connectedness. And probably the highest levels are more difficult to realize. I think this again is also shows a little bit the link with concept developments we are familiar with, but they show how a digital twin could be further developed more stepwise. Although it's rather, I should say, it's more a theoretical model, because in reality you can also go for another approach. I think theoretically it's an interesting model that shows what, again, digital twin is about. So just a summary of this first part of the presentation, where our ambition was to have a look at what already exists in the scientific literature, also what are policy reports, but also reports by the other players in our domain. What do they tell us about the concept? So we saw there was really an increased attention to the concept, many different definitions and interpretations, which sometimes make it difficult to agree what a digital twin theoretically is, but also how you could put it or should put it into place, but also some ideas on what are now the key elements of a digital twin. Then the second part of the presentation will look more into real applications, real initiatives to set up a digital twin. Now the majority of the applications initiatives we will tackle or present here can be considered as location-enabled digital twins. Also important to realize here that we try to address or to introduce digital twins at different scales or at different administrative levels. So you will see there's really a structure in the presentation trying to address many different scales or many different administrative levels. And we also try to include various application fields where certain digital twins are more generally applicable, trying to support applications in many different domains, while others are more focused on very specific use cases. Now I would like to start first with two initiatives at the EC level. The one on the left I already introduced before. It's about a recent European strategy for data, which, as I said, for the first time introduces the creation or the concept of digital twins. It in fact mentions one digital twin in particular, which is the digital twin of the Earth, which will be created, developed under the so-called Destination Earth initiative. And that's together with the Green Data for All initiative are key elements of the creation of the Common European Green Deal data space, which is one of the 9 common data spaces put forward or presented in this strategy. The concept of creating those kind of data spaces and in the end a single European data space is very central in the European strategy for data. So where you really have one single market for data and where data are open not only for the public sector but also for the private sector, academics, citizens. So that's quite prominent, or that's a key idea in the European strategy for data. And to that, there's a link is being made to digital twins. So on one hand, through the Destination Earth initiative, but overall, they consider the creation of those data spaces and the data itself are an important fuel to the realization of digital twins, where the focus so far is mainly on manufacturing. But I think this applies to many other domains, or we are quite convinced that it applies to many other domains, such as including the Green Data and the Destination Earth initiative already illustrate. But it's a part on the left. Then another initiative at the EC level where the concept of digital twin is introduced. It's about the digital twin of the ocean. It's also linked to the European Green Deal, and especially with a recent Green Deal call, which is a new Horizon 2020 call, aiming to support further additional research that is relevant or related to the Green Deal. So they have some additional money for a set of research and development projects related to the Green Deal. They aim to cover many different topics. I think there are 11 in total, structured around many different call areas. And one of these core areas is about strengthening our knowledge in support of the European Green Deal. And there, one of the topics proposed is about research around the digital twin of the ocean. Now, I think a reason why I introduced it is not to illustrate it, but also that it shows some topics, or that it shows a set of topics that really require further research before a digital twin could be put into place. So it's about research on new sensors, about how to deal with big data and AI technologies. The what-if scenarios, also here it's very important. Co-creation, I think that's an important element also. So bringing together different communities, different domains that could contribute to the creation of those digital twins. Then the link with data infrastructures and e-infrastructures, also important. And then also in the government context, what we very often see is the use of digital twins to deliver information to citizens. I think that's already highlighted here, but that it will become clear at many other initiatives we will present today. Not only at the EC level, but also at the national level, what is going on. We just highlighted a few countries here we are most familiar with. They have a set of elements in common, but also some important differences. So that sometimes they focus more on the geospatial domain. UK, it's looking more from the building construction side. But I think when comparing them, you see a lot of very interesting approaches. And on the right side, for instance, we show the UK approach. So we're not looking at, I'm not going to present, or we're not going to present them all to the detail, but just to show you that they're all looking at digital twins. Sometimes that's national digital twins, but sometimes more focusing more on bringing together many different initiatives within their countries and trying to exchange experiences, build up, realize interoperability, build up knowledge, etc. This is just a figure of one, so it's not a national digital twin, but it's linked to the developments in Australia, where they are also working more on the digital twin at a regional level, and more in particular in the New South Wales states. Now, the reason why I would like to show you this, because they have a very good visualization of what's also possible. You can also directly access already what they already have into place. So the 3D data and even real-time data. As a citizen, as a user, you can have a look at it yourself. So just if you would like to know more or see what it's all about, please check this website. The city level also very relevant, and probably, or maybe even the relevant where these, the level of where these developments with regard to digital twins are most advanced. Although you see different scopes, but also different levels of maturity. I think in the geospatial domain, a lot of digital twin developments are taking place at the city level. And you also see here an increasing move towards more collaboration, joint approaches, not only between cities, but also cities working together with a higher level of government. I think that's also important, that a lot of the digital twins already in place are situated at the local level. Just one example of the well-documented digital twins is the one of the city of Zurich. I think from a non-technical perspective, very interesting here is the degree of openness. So they try to open their digital twin in different ways by making the data open, by also preparing some applications through which citizens can have a look at the digital twin, by using the digital twin for public participation, etc. I think that's really a showcase on how you can make use of digital twin to increase the openness of your city. If we then go to a lower level, you see the digital twins of buildings, shopping mall, airports, many types of buildings and other constructions, where they prepare a digital twin of the building, which allows them to better link on how the building, the interaction between buildings, people, devices. So it's not only about the building itself, but also how people within that building and other relevant things in the environment of the building are linked to each other. I think that connection very important. Just two initiatives to show that it's not only about what's happening above ground, but also more and more digital twins underground in the sense of the underground infrastructure, so the cables, pipelines for utility, but also the soil itself. So One Geology, they're also thinking on how can they apply digital twins for geoscience, also an interesting development. Overall, I think what you see more and more in many of the government applications is the use of the what-if scenarios, simulations for the futures, where they see also use visualizations to look at the future. So imagine if we change one particular parameter, what would be the impact of that little change to so many additional parameters, but also developing thousands or millions scenarios at the same time, allowing really to better assess future scenarios. I think that's a key element, especially on the use of these digital twins within government. Just a set of conclusions when looking at these examples. So quite a lot of spatially enabled digital twins, different levels of development, and also to different extents relying on the underlying data infrastructures already in place or not. So the challenge is, on one hand, how can we build further on what already exists? So many countries, also we see they have put into place a spatial data infrastructure. How can these infrastructures contribute to the realization of digital twins? I think that's an important challenge. And then somehow related to that is the issue of how can we ensure the interoperability between digital twins. I think these are two challenges we would like to use as introduction to the third part of the presentation.
Hi, Danny speaking here. Do you hear me?
Yes.
Okay. So I will take over from Glenn to present a few ideas we investigated on the interoperability challenges with regard to digital twins. Next slide. Of course, the first big challenge is that if we speak about digital twins, and especially spatially enabled digital twins, we speak about a multitude of data. So the biggest challenge is the data challenge. In the right, you see from Anslik, their approach is that we have, of course, already for some time spatial data infrastructures, a lot of spatial data, base spatial data, but on top of that, more and more other information and data becomes available that we can connect to the spatial data and that can be integrated with the spatial data. There's data coming from the engineering, from on the environment, measurements, for example, air quality, on infrastructures, utilities, but also social and economic data. And the Internet of Things is providing data streams. In fact, all this is coming together. So we need really to look into how these different pieces can be bound together, which standards and protocols should be used, the technologies to be applied, etc. And it's only then when all these data are coming together that we can start doing more data analytics, start to model and to make predictions to simulate. And if we do that and we really can process the data in a meaningful way, then we can have new insights, have better decisions and better outcomes. In the Smart Cities Council documents, they speak about a real digital twin must have really different types of data sets and rely on different data sets, including, of course, geometric data and reference data that's still very valid, type of data we can find in typical spatial data infrastructures, but also a lot of asset attributes connected to these data, whether they are physical, natural, social, economic, also management data. And then the most important difference, of course, is the real-time data on various aspects. And therefore, we speak not only about 2D, 2.5D, 3D, but also 4D. So the dynamics is a key element and a key challenge in the new data. Next slide. So it has always been pointed out by Glenn, but if we really want to exploit digital twins at its full capacity, they need to have certain capabilities. And of course, what is very important is the live connection. So typical SDIs still mainly rely on relatively static data. And for example, certain data sets are renewed or updated each number of years or even better sometimes, but there is not yet a real live connection between the physical world and the digital replica. And then there's this challenge, always a challenge to integrate all these different sources, bring it together. We did that also, and we do that still now, bringing on our computer different data layers, different data sets together, and then we start analyzing. But when there is a real live connections, this integration becomes a little bit more challenging. What is also different, I think, that there is need for new visualization techniques, more advanced visualization of this real-time multi-source data. Because moving data, moving objects, for example, they require other ways of visualization if you combine them with more static data. And if we then try to analyze, but not just simply analyze them, but also simulate and make predictions, that requires certain models, certain algorithms to be built in to easily manipulate and use. And then, of course, there might be also an aspect of synchronization of the information. Maybe not all parts of the geospatial and all other data is to be visualized for everyone. There might be some parts of the data that should be secured. And therefore, we have some relevant developments, of course, in our geospatial field, going from sensor web enablement, the typical spatial data infrastructure, but already geovisualization is not entirely new, of course, but we might have new forms of that. Geo-artificial intelligence is emerging also, but will become more and more prominent, machine learning, this type of technologies. And the way to secure certain parts of our data will become also more and more important. Next slide. No, yeah, this one. Also, not only more data, not only the way we treat data, but also the data handling itself becomes a little bit more complex. This is an example from Richter et al. It's a scientific publication on an application in the field of transport and mobility, where, of course, static and dynamic data needs to be combined, 2D till 4D, where interaction between elements becomes important. For example, interactions between cars and other devices, etc. And where this modeling, this simulation and prediction is needed in order to, for example, predict traffic flows in this case. And this requires also more computer power, to do this real-time modeling and treating of data. And also the way we store the data. In the right figure, you will see that we do not have the situation anymore that we just store the data in one place, putting everything together, but you have maybe multiple storage, intermediate storage, etc. And you have, in fact, a process chain of combining and merging and manipulating the data, assessing the data, process it, fusing it again, maybe into certain pieces of information in order to provide it to, for example, end users. So the whole chain of also the data handling should be maybe automated, at least partially, and will change in the context of digital twins. So it's also clear that it's not only enough to treat and work with the data, but also to look into data ethics. And if we speak about end users that might not need to know about the complex processing and handling of the data, they need at least some geospatial data literacy to understand and interpret the data that is visualized. Next slide. In the UK, approach for digital twins is a very interesting part in their reports, where they compare how we actually handle or work in spatial data infrastructure and in Inspire in particular, and how these infrastructures and these communities can help and support also the development of digital twins. Of course, the focus in SDIs is a lot on spatial data models using standards, ISO standards, for structuring the data and to have kind of semantic model of a particular area. And of course, these models should be extended beyond the purely physical or functional representations. We should also act more on how we handle temporal changes over time over life cycle. This becomes more important in the context of digital twins. And also the governance of data and data assets and the processes becomes also more maybe complex, or at least they should be a point of attention. And then of course, the protocols for managing, securing and controlling the access to information becomes also more important in this context. And the conclusion of the report is not that Inspire is something else, something old, something not usable. On the contrary, it's kind of building block on which you can build further, but a digital twin should also extend what is called the foundation data model. Think about the reference data library, revise and enrich the architecture that integrates not only static data, but also these dynamic data. So also the approach and the way we describe it should be improved. So this report is quite important. It's from Millard's 2020. Next slide. In the geospatial world, some of you know, of course, the efforts performed by the Open Geospatial Consortium. They have for a longer time now a technology trends watch, which is, by the way, I think less than a week was renewed on their website, but which relies on the identification of key technological trends that might or will be relevant for geospatial standardization. And digital twins, static and dynamic versions of digital twins is recognized as one of them. And in the next slide, you will see that already OGC is through different domain working groups where the communities are together and working on particular sub areas. There are several of these working groups where already the digital twins is relevant and is treated during the meetings and in specific initiatives. There are already some reports out. I did not mention them here, but I've just mentioned a few of the domain working groups that are relevant in that perspective. Of course, sensor web enablement is a very important area. There is a smart cities domain working group where work since several years is already performed. 3DIM, three-dimensional domain working group, where they look more into the visualization part. Artificial intelligence in geoinformatics week is also a relevant week where activities take place that brings in and can contribute to the development and the establishment of digital twins. But others are mentioned here as well. So 3 dots are indicated to just indicate that there are many areas within the OGC where relevant work is taking place: citizen science, simulation and gaming, etc. But OGC is not the only one, and on the left side of this slide, you can see a figure just to indicate that the digital twins is bringing in interoperability challenges that is geospatial, of course. What OGC is doing, what ISO TC211 is doing remains very relevant and key, but also in other standardization bodies like IEC, ITU, etc. Activities take place that are relevant in the context of smart cities and have an impact on the developments of digital twins. And since sometimes there is a joint technical committee between ISO and IEC, the Joint Technical Committee 1 with advisory group 11 on digital twins that tries to streamline and to organize the work and try to bring these SDOs, these standardization development organizations together in order to build common building blocks for supporting digital twin developments, exchange experience, have kind of common roadmap to do that work because this is quite important for reaching this interoperability. Next slide. To provide then an example of another Horizon 2020 project called DUET. is an interesting one. That one is focused on digital urban areas, digital urban twins, it's called, where the idea is to use high performance computing and the cloud for better decision making. And the idea is to build digital twins for different cities. So there are 3 pilot areas. More partners are involved, but one is in Greece, in Athens. The other is the city of Pilsen, and then the region of Flanders in Belgium is the other one. And if I focus a little bit on the Flemish case, that's an interesting one because that starts from the policy level and the policy challenges related to what we call regional mobility, and also the link to environmental and health aspects. So the idea in this pilot is to explore and simulate the correlations between mobility, air pollution, health issues. So these are very important policy aspects to be monitored, to manage. So what they do and it's just a project that started last year, so it's still ongoing, is that they try to combine international, national, regional data set, but also with very local data sets, which are built mostly upon the Oslo semantic standards. And the Oslo semantic standards is the open standards for local administrations in Flanders that have been developed as part of the broader ICT developments. And they rely, in fact, on ISA2 core vocabularies, for example, the location one, the persons one, the business one, etc. So they reuse interoperability building blocks from ISA2 to really try to find an interoperability solution. Next slide, and I think that's my last slide, is to refer to the fact that in order to do so, DUET, but also in other smart cities developments, the Open Agile Smart Cities initiative has developed some recommendations and guidance for local authorities, for cities, to rely on minimal interoperability mechanisms. And that's just to mention that they want, or they already rely on more different building blocks and interoperability components from different standardization organizations. And what is very important is that they state that local authorities usually already have existing proprietary solutions. And the idea is to build on top of that interoperability solutions with APIs, with OASC data models, and integrate solutions in different applications that is usable for the marketplace. And so it's not only geospatial standards on which you can rely in this context, but there's also specific initiatives at European and beyond European level from other standardization organizations like ETSI. But for example, also in the context of Europe, you have FIWARE developments and other areas where guidance and architectures and standardization building blocks have been developed, and that can be reused in this context. And so this DUET project, and also in other cities where they develop smart cities applications, they are looking into this way of developing standards and relying on similar standards throughout different digital twins. Next slide. That's my conclusion, I think. Yeah. So the digital twins are clearly challenging in the sense that they are based on many diverse and very dynamic data sources, not only the typical static reference data sources, but also very dynamic information and data. And these need to be combined, visualized, and understood very well. This means that we need another view on interoperability with technical challenges, semantics challenges, also organizational challenges. So collaborating between different standardization bodies is of utmost importance. And you see that the trend is to look into more simplified, between brackets, standards, smaller components, small building blocks that everyone can use in the context of digital twins. And I want to hand over for the fourth part to Glenn. Thank you.
Thank you, Danny. I will keep this part brief to make sure that we're already a little bit behind schedule. It took us some more time to explain what it's all about, but we would like to, we hope that some of you can still stay to participate in the polling and the discussion. I just have one slide with summarizing the concluding remarks and what we consider as key challenges for the future. Now, the remarks we already highlighted through the presentations. We believe and we hope that we were able to demonstrate that geospatial data, tools, and technologies could be seen as important enablers fuel to digital twins. We believe that already the data in place, technologies, infrastructure in place should be further assessed, and work should be done to assess their potential contribution to the creation of digital twins. So what are the data, what are the standards we already have that could play an important role to the creation of these digital twins? That's an assessment we think is essential. Because further upgrading after these afterwards could be important to better, should I say, or further improve their contribution to, again, creating, using digital twins. I think that's, we believe, as a central message. A lot is already into place, not only from our domain, but also from other domains. So it's important to build further on what already exists. What are challenges and priorities? Like I said, it's not only our own domain, but there are many different relevant communities. So Danny already showed that from the perspective of standardization, where each of these communities, they should talk to each other, they need to be brought together. That's also partly what we aim to realize through this webinar on the topic, bringing together experts from many different domains and looking at hoping some exchange of knowledge, experience. We believe the issue of skills and competence is also very important, also linked to the overall objective of the ELISE program. What are now particular skills and competencies needed to allow people to go ahead with these digital twins? But also to think further about the benefits, the impact, use cases. So how can these digital twins, when they put them into place, how can they play a role in the digital transformation, not only of government, but also in society? That's also something that the ELISE project action could look further into. What are now the main benefits? Why should we go ahead with the implementation, creation of digital twins? Maybe to add on this, we have had a quite positive presentation, but probably there are also quite many potential risks in the creation of these digital twins, risk problems that might be associated with these digital twins. It's also important, or it could also be a line of action for the future to better look at what are potential risks of building these digital twins. What could we do to avoid or minimize these risks? So with these final words, I would like to end our presentation. I hope you liked it, but I'm especially looking forward to your input, feedback, and ideas for future action. Thank you very much.
Thank you very much, Danny and Glenn, for this very interesting and exhaustive presentation on many aspects of digital twins. So now we are coming to question and answers and discussion section. So before we are going to that, we would like to ask you a bit more, some questions to you. So we'll start another poll. And you're kindly asked to answer a few of those questions here. So are you aware of any other initiatives on digital twins you would like to share with us? The second question is about the challenges. So in your opinion, what are the biggest challenges of digital twins? Here you are asked to select up to 2 choices. There's a multiple choice question. And last but not least, in your opinion, are digital twins ready to embrace location information? So please start voting now. We'll take another 20 seconds for that, and then we'll continue with the answers, comments, and questions. There's been some comments already in the chat window, also some question. We have also some interesting people here that may want to comment the presentations and some additional views from their side. So please, another 5 seconds, please vote. So we'll end with the voting now and share the results. So you said some of you said you are aware, so another initiative. So please share the initiatives in the chat. We can comment something on that later on. Among the challenges, so the most of you put as a top challenge lack of standards and interoperability, then quality of data. And most of you are of the opinion that digital twins can embrace the location information. So starting from the challenges, the lack of standards, interoperability, we have people here from OGC and ISO as well. So maybe before we go to the direct questions, I would invite maybe Bart from OGC. There is also, I think, it's Peter from ISO, Sankey. So please, Bart, would you?
Yeah, Simon, happy to do that, and thank you for asking me on. There's so many people on the call that I recognized. Hey, everyone, it's so good to see you in these dire times, so that's good. Great briefing by all, Glenn and Danny. Thank you for that. I always learn during these calls, and good to see things like CAD, GIS, and BIM coming together in the digital twin. What I believe is interesting here, apart from, we've seen that the biggest thing is the interoperability of the data. Yes, in digital twins, we're going to bring together a whole, gigantic amount of data. And if you then have to start worrying about, how do I interpret this data, you're going to lose a lot of, your time, computer's time, and all that. So we need to get much better at using well-known data. Danny and Glenn alluded to it, but let me just highlight a couple things here. And that is, in a digital twin, for me, it's fast-moving data that you're going to combine with slow-moving data. And that brings its own particularities on how do you bring sensor data, the fast movers, together with that slow-moving data. So that's, for me, is an interesting topic. To what Danny presented on the data, just highlighting the use of semantic data. I believe that's one that we need to underline here. And so that's one to have. We've seen the OGC activities on the digital twin. Actually, we're going to have a location powers in November. That'll happen either in New York City, who knows, hopefully, or either virtually, and we'll focus specifically on the urban digital twin. There's many digital twins out there. I think you had it up there, Simon, earlier on Apollo 13, which was a great example indeed, how to switch on the system and not blowing out the fuse in the module was a big one. And so they were very happy that they had that digital twin. Our focus will be on the urban digital twin. And so that's in November. And so let's see if we can bring some of these folks on. And yeah, OGC is happy to contribute to any of the work in digital twins and vice versa. If you know of good use cases, contact me or contact a lot of folks on the call here, actually OGC members. Thank you for that, to contribute. So yeah, Simon, thanks again for having the call and raising this important topic. So.
Yes, thank you very much, Bart, for sharing your comments. So I think Peter would like also to share from the ISO perspective, since we are talking of the interoperability and standards here at the moment.
Yeah, so hello, thank you for asking me to comment, Simon. I'm glad to have Bart on there commenting too. For the others, when Simon asked, I said, well, there's other people on this call like Bart. Also acknowledge Sung-Ki from Korea, who chairs the ISO TC211 working group that sort of looks after things to do with smart cities. And Chris Boddy from Australia is on the group, and he and I have been the OGC's representatives in the working group that was mentioned between ISO and IEC looking at smart cities. And for TC211, I'm in the advisory group that's there on digital twins particularly. So I'll say a little bit about that. That digital twin advisory group is really coming from the manufacturing industry angle. And with Songqi, we've been making sure that they're well aware that the concept digital twin is now being picked up in the smart city world, and I seem quite happy with that, to be honest, and we're able to bring them extra use cases and examples, and so their role is to advise across the whole of ISO, IC, JTC1, so that's all the sort of computing standards on what the challenge of digital twins brings to those areas. Someone that's just coming here, so OGC involved in that too, so OGC very much involved with JTC1 as well.
Okay.
And you're saying it because you just wrote it there, but I would say in the UK, the work for the national digital twin is really a federal digital twin. So it's looking at setting, it's set out some principles, it's then looking at setting out interoperability approaches to manage to pull together digital twins such as has been developed for Crossrail. That's a new underground railway through London or under London. It's not quite open to the public yet, hopefully next year, although they've had to stop work for a few months this year, so that might delay it again. But like many modern railways, there will be a digital railway to go with it. So how do you integrate that, which has been built as a construction and engineering digital twin, with a digital twin, for example, the UK's National Underground Asset Register pilots, which is OGC have been helping us with, which are about retro surveying existing underground assets, so water mains, gas mains, sewage, those kind of things. And so they've taken, those things actually have a very different conceptual view of what the world is made of. So although I think it was Danny's, one of his slides pointed out that the UK statement of saying we need a core data model, and then we need some reference libraries, and we need an integration architecture, that has some similarity to Inspire's approach, but actually the core reference model of it is likely to be a very abstract kind of ontology that can cope with the different ways of looking at the world that there are between construction, facilities management, engineering asset management, and the geospatial world. So actually I'm going to be presenting to them on the general feature model that underlies the Inspire model and comes from OGC and ISO TC211, in which the world is divided into things that have attributes, except when it isn't, of course, because then we have also the coverage model, which the National Digital Twin in Britain have found a very interesting concept that they'd like to know more about. What do you do when the world doesn't conveniently divide into things? And then the old, well, not that old, but current question of whether those things actually belong in classes or whether that's just an arbitrary imposition on the world that we tend to make. So it's, the danger with that is it's very abstract. And I think, that again, in Danny's slides, he mentioned the OASC's work on minimum interoperability. I never remember what the other M is. Bart first introduced me to the concept, and that is in a much more practical approach of saying we have these things that work, let's get on and do it. And my concern in the UK is that we're perhaps going to be too theoretical, but that we have got a push on that during this year we define that theoretical framework. It's just got to be theoretically sound enough to work across a range of domains. So I think in terms of standards, it's a very good question at the moment, whether this is an area where good practice is mature enough that actually standards would help or whether they would hinder. So I put in the chat, I think sometimes that in this area there are too many standards. So that there are standards, ISO standards on facilities management, on equipment management for all kinds of industry. Okay. And of course our geo one. So it's how to get the standards to work together, standardizing the standards.
Okay. Thank you very much, Peter, for that intervention. So before we are going to there's some question as well, I would like to remind you that some of you mentioned already in the chat window some of your challenges, so answer the Q2 question. So you may want to read them in the chat window. So before we continue, I would like to invite, I see there is also a colleague from DG Connect, Andrea Halmos. Maybe some comments, some additional comments, some views from your side. Please, Andrea.
Thank you very much. I'm trying to turn on the video, but it may not work. In any case, I work in the unit that deals with smart mobility and living, so smart cities, and I was very pleased to hear so many different references to it in the context of digital twins. Because as many of you will know that we've been really looking at how to have the digital transformation of European cities, in particular now, of course, with all kinds of more advanced digital tools and solutions. And of course, in this context, the idea of helping cities to set up their own digital twins is also something we're looking at. Of course, we're aware of these examples that were mentioned, like DUET or the work in Flanders and Helsinki and some of the others, and also at an international level. But I'm now realizing that it's actually a topic that is certainly on the agenda of many of the organizations online, and also how the location data could be extremely helpful for making it happen. Now, what from the Commission's point of view we're trying to do is actually support not just one city here, one city there, but really somehow to create the necessary capacity for cities to be able to implement their own digital twin, and also identify some of those key building blocks that you were also talking about, which could then help perhaps set up some kind of a structure or a modular structure that will then help cities be able to quickly identify the use cases, the areas that they would like to use this digital twin in, and then also help us quicker to scale up. And one element that has clearly come out from all of your presentations is related to the data, and also from the answers to the question around data interoperability, access to quality data, and so on. And so in this context, I also wanted to mention that in order to support these initiatives, and of course, ultimately to help cities make better decisions for their citizens, we're actually helping or supporting the creation of something called the European Smart Communities Data Space, which would identify a little by little, of course, growing number of data sets that would be of relevance, that they would be easily accessible and reusable for the same kind of data sets in any city in Europe, or any stakeholder that would like to create services on top of that. So please stay tuned. A lot of what I was just saying is related to the data strategy that was mentioned earlier, and is related to a new funding program called the Digital Europe program, which we're hoping to use for supporting these financially.
Thank you very much, Andrea, also for your views and inputs. Before we continue and starting to wrap up, I would like to pose a question that was in the chat window to Danny and to Glenn. It came from Lorenzino Vaccari. Which group of real things do you think will be more cloned digital twin in the near future? Real things at macro scale, like a digital earth, ecological systems, medium, like a biological system, or at micro scale, microbiological systems? So what would be your opinion on that, Glenn and Danny?
Well, it depends a bit in which area, because in my opinion, the digital twins related to smart cities is going in the direction of the real detailed level of information up till the level of moving objects in a city, not only the building, not only the urban fabric, to say so, but really everything that is happening in a city. So even speaking about in the case of the examples shown already before, mapping furniture, mapping trees. Also, the green area is not the park area anymore as an area, but rather the individual objects, let's say, and the relationship between objects. So I think there you go rather to the micro level, while if we speak about the ocean digital twin, for example, that is aimed to support the Green Deal, for example, there, of course, I think they will start more at a higher level to try to model the ocean, which is a vast area. It's not, but they have also the ambition to also zoom in on particular subsets, and for example, how biodiversity is evolving in certain areas of the ocean, which can be very local. But that's in my opinion a very big challenge, and also having a digital twin for a very vast area, let alone for the full globe, is a very challenging endeavor. So if we will directly reach it, I am doubting that, because I think the reason why in cities there is already some, well, not fully operational maybe, but there is some efforts ongoing. The ones at the global level, for example, are emerging now. And I'm also curious how that will evolve and how the policy related to these twins will, and the governance will happen. That's not so very clear on me, because so many communities are involved. But okay, he was referring to examples on the biological
on different levels, actually.
Yeah,
so the more question about the leveling, so
yeah,
macro, medium, and micro, but there are some examples, but there are biological, microbiological, and the other one was digital earth or ecological system. Yes.
Yeah.
Okay, so I hope Lorenzino, you're happy with an answer. We are pretty much tight on time. I had the impression we could have had a very long and fruitful discussion even further, but unfortunately we will need to end slowly. So before giving back floor to Lorena, I would like to ask you a few further questions. So there is another poll here. How would you rate this webinar? So what was your satisfaction of this webinar, giving the information about the digital twins today? So you're not satisfied, satisfied, more than satisfied, very satisfied. And in the second part of the polling question is as well, what would you like to see next? Select the topics you're more interested in. So maybe select up to 3 topics, multiple choice question, please. So please take 15-20 seconds, then we will stop with polling. We are very much appreciating your opinion. Another 5 seconds. Okay, so we'll share the result now. So at least not many of you give an answer on the rating about this webinar, but at least you were satisfied, also very satisfied and more than satisfied. Regarding the next webinar, so the top selection was a topic on the smart cities. Yes, most probably they will be one of the topics. Digital platforms as well, and Internet of Things. So, okay, so thank you very much once again for this fruitful discussion as well. Thank you for presenters and commenters as well. So at this point, I would give floor back to Lorena. So please, Lorena.
Yes, thank you, Simon, and thank you for all the people who participated in the Q&A session.
Lorena, we lost you.
Can you hear me?
Yes, now we can hear you. Please speak.
Okay. So I don't know exactly where I remain, but I'm basically inviting you for to attend our next webinar. It will be on geospatial data and artificial intelligence. The registration link is already available. So if you feel that this webinar is of your interest, please feel free to do it. And with this, I will close the webinar because we are a bit late already. I thank you very much for having attended the webinar. You will receive soon an email with all the details of where to get the supporting slide, and also we will upload the recording of this webinar so that you have it at hand if you want to replay or see some detail maybe that went too quick. And that's it. Thank you, and I wish you to see you soon again.
Thank you all. Bye-bye.
Thank you.
Very good.
Thank you. Bye-bye.